Hey, this is Joe at graybenchelec. Welcome back to the pedal teardown series where I take apart new and interesting pedals and show you what's going on inside. Today we have the Lantern Manufacturing White Oak. All right, so we got the White Oak from Lantern Manufacturing. This is a two-sided fuzz. Maybe you haven't heard of it. It seems to be pretty popular. They're sold out on their website right now. I think this company got a shout out from GHS maybe. Anyway, one popped up on my Reverb feed and I know I had seen these on Reverb just scrolling through the people I follow to kind of get a scoop on what pedals should be featured for the channel. And so I saw it come up and I figured, hey, let's grab it and check it out. Considering that it's a relatively new or boutique pedal, I figured it'd be worthwhile to have a look at the info sheet that they include. We'll just read a little bit about it. So White Oak, Lantern Manufacturing. It is a dual parallel fuzz with two uniquely voiced circuits. General emphasis on the mid frequencies. Standard DC control. So going over the controls, volume, center volume here, controls overall volume of the pedal. The blend control blends between the two fuzzes. Turning the knob to the right or left increases or decreases the presence of the comparator or square wave fuzz that's on the left here, or a vintage style harmonic fuzz on the right. Usually when they say vintage style harmonic fuzz, they're talking about Big Muff. And depending on gain settings, may not be even split. Gain 1 is the gain for the comparator or square wave fuzz. Tone 1 is for that fuzz, and it's a gentle mid boost at noon, or bass or treble depending on where you turn the knob. Gain 2 is the gain for the Big Muff side, or the what do they call it, the vintage harmonic fuzz. And tone 2 is when you turn to the left, it says it is like a mid boosted mode, so like a honky mid or a cocked wah sound. And then turn to the right is a full EQ, full spectrum sound. So that is the info sheet for the White Oak with some suggested settings. As far as the exterior of the pedal, we have a powder-coated 125B size enclosure, top-mounted quarter-inch jacks, DC jack. DC jack is PCB mounted. Interestingly, the DC jack cutout is rounded in the corners rather than squared off, which may mean that it is machined or milled out rather than stamped. Usually for the stamp, you'll just drive a broach or whatever down through the piece of metal. It'll have sharp corners, but in this case, they're rounded. So just a little detail. The controls are all here on the top. We have these nice white knobs, nice and slim because the knobs are packed in there pretty tight. Foot switch is a latching type, probably a standard 3-pole double throw. The actuation pressure is pretty light, so it might be one of the Gorva style with the light green body. 5mm LED, red LED, indicate the pedal's on or off. And the graphics are all in a white silk screen. That is it for the exterior of the pedal. Let's go ahead and crack it open. All right, I just wanted to take a second to talk about mounting the PCBs with these Neutrik, or I've seen Switchcraft. This means all kinds of companies make these style PCB-mounted quarter-inch jacks. But as far as I understand, or the problem I see, and I've seen this on multiple manufacturers now, is they're not using what are supposed to be included plastic washers that come with these quarter-inch jacks. And the issue with that is when you tighten down the external nut here, you're tightening. First off, I don't love these jacks because it's a metal nut going into, a metal screw going into a plastic nut, which isn't great for longevity. But when you need isolation, you kind of don't have a choice. But besides that, without these plastic washers being used, when you screw in the external nut here, and you don't have those washers, you can see here, if the hole inside for the enclosure, if that is large enough, then the throat of the quarter-inch jack here can fit through that hole, just like this one's doing here. And so when you tighten down this nut, what you're tightening against or what you're pulling against are the solder connections on the board. And that it just rubs me the wrong way. And it feels like it's not a good idea for the longevity of those solder connections of the pads on the PCB. If instead we introduce some of those washers, which as far as I know, these jacks are supposed to include the washers. So they just go over like so. And you need enough so that it fills the gap between the enclosure and the body of the quarter-inch jack, like so. Put that back in there. Put the nut in. So now, when we tighten this down, What we're squeaking against now is the actual plastic body of the 1/4" jack rather than the solder points. And with this, we should be able to actually tighten down this 1/4" jack without having to worry about the solder points. And we can actually snug it up and keep these things from backing themselves off and keep them from putting excessive force on those solder points. So I feel like these plastic washers, they're included for a reason and we should use them. All right, so here are the internals of the White Oak from Lantern Manufacturing. We have a dual PCB setup here, just the main signal board and then the little daughter board for the 3-pole double throw. Speaking of the switch, this is not one of the Gorba switches, those are green. This is black. I don't see, there actually is a manufacturing mark, but one I don't recognize. Hopefully you can see it in the corner there. It's like a little half circle with a squiggly line inside. Not familiar with that brand. If you know what brand that is, leave a comment. The enclosure here is a unmarked enclosure in terms of manufacturer. We have some deliberate removal of finish or powder around the 3-pole double throw jack, but I don't see any way, I don't see how that is connecting. Perhaps internally that's connecting one of the lugs here to ground on the enclosure. Could be. All right, so top side on the PCB here, we have 4 8-pin dip packages. Everything is surface mount. All of our resistors, capacitors are all surface mounts. Of course, the potentiometers are not. These are the VIMEX, I think it is, VIMEX potentiometers. The values here, a linear 500K for gain, 1. A audio 100K for volume, a 10K audio for gain 2, a linear 100K for tone 1, a linear 50K for blend, and a audio 100K for tone 2. There's our 5mm red LED. There's also a red LED on top of the board here, probably a clipping diode. We have some larger surface mount capacitors here, probably filtering in the power supply. We also have some smaller 10 microfarad surface mount caps, which are probably bypass caps for gain stages, something like that. The ICs here, let me get the part number. Yeah, so all 4 ICs here are Texas Instruments RC4558 dual op amps. There are the Neutrik 1/4" jacks, which we already looked at. PCB mounted DC jack. Not a ton to see here. I don't see any components mounted to the bottom of the PCB. One thing that's slightly concerning is that these potentiometers do not have the covers for the back of the potentiometers, which means that if for some reason, for example, this pot here, if this was to flex up and touch the 1/4" jack there, you could have a shorting scenario, which could be just as bad as the signal cutting out or making a weird sound, or it could potentially lead to a short circuit in the power supply, which wouldn't be good. We do have a pot here underneath the DC jack, so that wouldn't be good if that were to come up and touch there. On the bottom row here, these pots don't need the covers because there is no bottom side connections. It's all surface mount on this side. But up here we have the 1/4" jacks and the DC jack, so these 3 pots should have some sort of protective material between the pot backs and the board to prevent that shorting. The little daughter board for the 3-pole double throw is connected to the main board with a little ribbon cable. The construction, the surface mount components and whatnot, it's all impeccable. It's all super straight, even soldering. It looks like it was probably done by machine. So to talk quickly about the 2 effects, we have the vintage harmonic side, which is the right side of the pedal. Like they say in their documentation, and just generally speaking, that's probably a big muff style, an op amp big muff. We have op amps available for that purpose. The left side is what they call a comparator or a square wave fuzz. I know I've seen comparator fuzzes going all the way back to Craig Anderson's book, the Electronics for Musicians book. There was a comparator fuzz in there. The simple gist of a comparator fuzz is we provide an op amp some reference voltage, and then when the signal crosses that voltage, it allows the output to go through. When the signal falls below that voltage, it cuts the output out. And so what you get is that square wave where you're coming through and you have no signal, and then all of a sudden you cross that threshold and it jumps up, and then you have your square, and then it comes back down when it falls below the voltage, and you do that over and over again as the signal passes through thousands of, frequency, whatever it is, thousands or whatever, times a second, and you get a square wave output. That's the super simple and not particularly well understood myself version of what a comparator fuzz does. I've seen comparator fuzzes as simple as 1 signal op amp stage. This we have 4 dual op amps, so 8 total op amps available. So I don't know exactly how they're doing the comparator fuzz, but that's the general idea. All right, so that is it for the internals on the Lantern Manufacturing White Oak. Let's go ahead and put the pedal back together. All right, I hope you enjoyed the teardown on the Lantern Manufacturing White Oak. If you have any questions or recommendations for a pedal you want to see on a future teardown episode, let me know in the comments. If you enjoyed the video, I'd appreciate you hitting the like button and subscribing, and hit the notification bell if you want to know when I make a new video. I'm Joe from Graybench Electronics. Thanks for watching.